So, sorry about that. Now, a little. So if I'm not careful, it'll either run up against this wall or it will run up against this wall. So I want to pull it far enough away from both walls. So the way I do that is I say that NP hat has to be greater than or equal to 5. So the whole problem was NP was 0.14. So there wasn't enough room for it to come out. So if I make it 5, put the highest bar here, then it's got room to go up and room to come down. And to make this easier for the other side, I just say NQ hat has to be greater or equal to 5. If those two things are true, the highest bar is in the middle, it's got room to go up, room to come down, it will be normal enough. I'm not sure how you guys feel about that.
Wait, where'd you get 5?
Same place I got 30.
Oh.
That's just a quick way to say that.
It doesn't matter what the actual percentage of P or Q is, as long as you use these formulas, it'll, it's, however lopsided it'll first appear, it'll pull the distribution towards the middle.
No, if I'm given a situation where this is true,
Or what?
where these two things are true, then it will be normal enough.
I just want to be a question clear. N times P hat.
Yes,
Okay, just one.
because otherwise P hat can't be bigger than 1, because it's a probability, it's a percentage. Yeah.
Yeah.
Cool.
Sorry. I'm struggling to understand the big concept, but in shorter, smaller world, as long as these two formulas are true, similar to if we're above 30,
Yes.
we
Good.
just assume that
This requirement takes the place of n greater than 30. So if I'm talking about means, either they tell me it's normal or n has to be bigger than 30. If I'm talking about percentages, these two things have to be true. If either one of those statements is not true, you officially can't do that shit. Right? That would be a stats 2, which we don't teach here, which makes me sad, but oh well.
Like here at Grossmont?
Like your Grossmont, that's right. They teach at other schools. What's wrong with them? I don't think any community college teaches stats 2, to be honest.
Wait, why don't you teach it if you know it?
Huh?
Why don't you teach it?
Because it's not here.
he's not going to get paid to do
We
it.
probably wouldn't get enough demand for it.
Yeah.
But you never know. I could try to make it and see what happens. You good? Okay.
Like you don't have enough going on.
Yeah, I got too much free time. Where did they put my? There we go. So let's see here, Nick. So now we're going to go on the other side. No cute or ugly picture. You can make your own choice. There's none of that yourself. So we take a sample of 659 registered voters and find that 459 of them plan to vote in the next election. I want to find the 90% confidence interval for the true percentage of, true proportion of people that will vote, I should say. I think I changed this to be, because we have the next election coming up. P hat is the sample percentage. If I just told you we talked to 652 people and 459 of them say something, what's the percentage of them that said something? What's the percentage of the people that said they're going to vote? How many out of how many?
459 over
459 out of 652. So sure enough, that's what this is. I don't know if you guys remember from binomial, X is the number of successes. How many people said yes, they're going to vote? 459. Out of how many total people?
652.
Now, you ready? P hat and Q hat must always be rounded to at least 3 decimal places. So what is 459 divided by 652?
0.704.
Can somebody tell me what Q hat must be then?
0.296.
Good, because together they have to make 1. No matter what clothing they're wearing. Okay. Of course, what's N? Now this is another place people make a mistake real easy. What is N? 652. It's always the total number. N is always the size of the sample, which is the bigger number. Now you guys do this. Don't say a word. Just do this. And I'll see if anybody notices a shortcut. Check those two things to make sure that they do what they're supposed to do. I'll do it the long way and then I'll show you a shortcut. So n is 652. What do we get for p hat?
0.704,
So what is n times p hat?
459.008.
And then n times q hat will be 193. 192.992.
Yeah.
Look at Jeff go! Sorry. Very quickly. How did I calculate p hat? Then I do x divided by n.
Yeah.
So what's n times p hat? It's equal to freaking x, yes?
1 minus this.
N times p hat must equal x. Why didn't I get exactly 459 here? Because this number was
Round.
rounded.
Oh. What?
How did I calculate 704? I did n x divided by n. If I multiply by n, that's n times p. I already know it's going to be 459.
Oh, right.
Why wasn't that exactly 459? Because we rounded this number. So what's the shortcut to figure np hat? The number of successes you're given. Does that make sense? If not, just do what we did here. What does this mean? What is our result? What do our results mean?
Way above 5, so we're good.
Yeah, they're at least 5. Approximately normal. Check. Okay. So now what are you allowed to do?
Use the chart.
Yeah, use a chart. So I want to be 90% confident. We just looked that one up. Does somebody remember what that was?
1.645.
Cool. There's the formula that we created earlier, right? Just written so you can actually read it. So if you would take a moment, please, and do it. Calculate your confidence interval. Yes.
Is my z times that also my error bound in the formula?
Oh, here. Yeah, this is still your error. Yeah. So I want to point, now I'll point it out in a minute. Yeah. Now this one did get a little tricky, putting it in your calculator. Gotta make sure that all of this is inside the square root. So it kind of matters which calculator you have, how it represents things. So I have the nifty little calculator where the square root symbol just gets bigger. So I can tell that all that stuff's in there, yeah.
How do I make it all go under the square root?
Yeah.
Because it's going to divide. Because when you divide,
You don't-
square root.
Oh, I see. Don't do the 704 part.
No, I know.
So you have the one, okay, so what you want to do is do not close the parentheses until you're done putting everything in.
That's it?
No, we want one more than the mean, so 4 decimal places.
Yes. One more than this number, yeah. So I get 0294.
Yep.
Just to show you real quick. I'm gonna change this to be classic. So now if I do this again, 1.645. Does anyone have a calculator that looks like this? Does this? Okay, so all you do not close that parenthesis. Because when you close it, you're outside of the radical, right? I want all the rest of the shit to be in there. Now I close it. Thankfully I get the same answer. Yes?
Real quick before we move on, you might go over once again just how to get this, how we got the z-score from this.
Yeah. So we just did it, but it's the little baby chart. 90% confidence, so that's 1.645.
Oh yeah, we already
Yeah.
said that. Cool.
So it's always nice when they give you a 90, 95, 99, because it's right there. You know I'm not always going to do that. Right. So my error is 0.0294. So now I just got to, now real quick, let me show you. This is kind of silly, and it's not a big deal. See the little stow button? See it? You don't have to ever do this. Stow in X. So I'm going to store that number in X. So now I can do, what was it, 0.704 minus X, 0.704 plus X. Shlabam. Right, so that's just, it's just the store into a variable is your most immediate way to get a memory location that stays. So now X just has that number in it forever until I change it. That won't mess anything up, trust me. So then I go from, what do I get, 0.675 up to 0.733, I believe.
Oh, do we round that back down to 3?
Yes.
Even though we're adding a 4 decimal to a 3 decimal.
The reason we do this for one more place than this is so that this rounding comes out better. Your interval can have the same number of decimal places as this guy. We take this one more place out just to be a little more accurate to that decimal place. And to be really, really honest, I could have taught you guys significant figures. Does anyone know what significant figures are?
Yeah.
See how excited she is? Okay. In math, we call them significant digits, just to be different. So take a moment and see if you can write this. I'll give you one clue. You always have to have units. And the units here will be percentage. So change your decibels to percentages.
Could we also convert our, just move 2 decimals over, right, for the,
Yep. So we are 90% confident that the interval 67.5% to 73.3% contains what?
90% of the,
True proportion of people that we vote.
Good. The true proportion or percentage, it doesn't matter, of people.
just like my thinking, I wrote it backwards, I don't know if that changes it.
It does. It's very important. Okay. This is really kind of silly. This seems very semantic, but it's too bad. If you say we're 90% confident that the real percentage of people is between this and this, you're not quite right. Very quickly. The true percentage exists, correct? There is a true percentage of people who are going to vote. Does everybody agree with me? We just don't know what that is. It exists. Any interval that any group makes can fall or can have an inside or outside. So I am such and so confident that the interval I made actually catches that percentage. If I say I am 90% confident that the percentage is in my interval, that's backwards. That's like the percentage comes later. No, it exists right now. I'm trying to catch it. I know that seems very picky.
No, it sounds like the same thing.
That's what I mean by picky.
Oh,
Picky meaning if you change the order of the phrases, it's not correct. That's picky. And it is just because this way captures the idea. The true percentage exists. It's out there, like little Pokemon. I get a p hat, and I make an interval, and I'm hoping I catch it. Somebody else makes a p hat, and they make an interval, and they're hoping they catch it. So anybody who makes an interval is such and so confident that their interval caught the percentage. If I say, I am such and so confident that my interval, that the percentage is in the interval I created, it's like the percentage came later. It's like it falls into my interval. It's backwards. I really didn't even want to talk about that. But I want you to understand the wording of this is important. It's always, we are such and so confident that the interval we made contains the true whatever. Okay. Statistics is always exciting because it's sort of like the intersection of English and math.
So the order affects this problem, but not our prior ones, right? Because this is.
Order affects every confidence interval.
Or whether it's.
So every time I've written a conclusion, it's always been the same format. So just to kind of cut to the chase here, if I took this, everybody agree with me that's the error part of this? Like something like Bessie, I think, pointed out earlier, this is the error. If I set that equal to this and I solve, I multiply by rad n and divide by e and I square both sides, I end up with this. So here's what's really weird. If I'm stepping into a situation like part A, how many people would we need to survey to be within 3% of the true proportion of students who pass statistics the first time around at 99% confidence? Do we have any clue what P hat and Q hat are?
No.
We don't have a clue. So what's our best guess? So if I said, what percentage of the people next door identify as male? What's your best guess? 50-50. That's your best guess. Now, real quick. That's unsatisfactory to a certain degree, right? It's weird to hear a math teacher say something. Here's a very mathish way to look at this. I really want this to make sense. If there's a part of the whole situation I am not sure about, should that force me to take more people or less?
More.
More. If I make these 50-50, 0.5, 0.5, mathematically that makes n the biggest it could be. If I make this 0.49 and 0.51, n will be a little smaller. So if I make them 50-50, that makes me be conservative, which I must be because there's shit I don't know. Does that make sense? Maybe? So in general, if they don't tell me what P hat and Q hat are, I guess they're 50-50, 0.5, 0.5. I think in the book, real quick, what is 0.5 times 0.5? What's a half times a half?
0.25.
So in the book, I'm pretty sure somewhere they have this formula. And it is only for if I don't know P hat and Q hat. Because then they're both 0.5, 0.5, and what's 0.5 times 0.5? 0.25. So somebody help me out, 99% confidence. Is that in our little baby chart?
Yes.
Yes, what is it?
2.575.
Thank you. And what's my error going to be? Here's where you got to be careful.
3%.
So what do I put in here for E?
0.0.
Good, 0.03. 3% is not a number, it's a made-up thing. 0.03 is the number. And then, of course, whatever the hell that is.
Wait, where'd you get E?
In the problem, within 3%. So up here, for example, in this problem, a sample of 652 got me to be within 3% roughly. You see that? Isn't that within 3%, roughly, if I round that up a little bit? Okay. So here, a different kind of problem. I still want to be within 3%, but now I'm curious how big of a sample it's going to be. Let's see, 100, 100. stop trying to do that in my head because I'm starting to get ahead.
How do we find the Z? The two.
Oh, 99% confidence, right?
Yeah.
Go back to the little baby chart. 0.99.
I keep forgetting that.
Yeah, yeah. I could do the old-fashioned way. 99% inside is 1% outside is 0.005 outside. If I look up 0.005, we get the idea, Jeff. I don't care. Look at me still going. 0.005. I get there. Asterisk. Follow it down. 2.575. Okay, yes. So a little baby chart, just a little shortcut. Anybody get this? Save me from myself, please.
1841.
42.
Sounds like a good year. 1841 point stuff.
Yeah.
Yeah.
So then you round it up to 1842.
Okay. Got it.
Oh, I remember this problem. Oh boy, sorry. This is where I made a fool out of myself and said something about Christopher Columbus. I'm like, wait, I was 16th. So I just wanted to relive that for you guys. So I would have to take a sample of 1842, correct?
Yeah.
Have you guys ever heard the phrase preliminary study?
No.
What does preliminary mean?
It's an initial study.
Initial, good. So one reason you do a preliminary study is for statistical purposes only. If I knew what p hat and q hat were, I could take my n down. Because 50-50 is what forces n to be the biggest it could be.
Mm-hmm.
So maybe I can find it, I need not quite at 1800. That would be great. It's going to take a while. So if I knew that if I took a preliminary study of 42 students and I found 31 of them passed the first time around, what is p hat?
0.738
How'd you get that?
divided 31 by 42.
Kick ass. So you get 0.738, is that what you said?
Yeah.
So what's Q hat? Good. What makes 7 9? 2. What makes 3 9?
6,
What makes 8 10?
10, 2.
1 minus any decimal unless someone works that way.
Did you
It's awesome.
go back up? I got a completely different. I think I entered something wrong.
Where are we at? Sorry, up here.
To the right. To the right. Okay, so
So square that.
wait, why are we squaring? Why are we squaring these chords in the formula?
Yeah, and also at some point I got to square that z is outside, so it's going to get squared. Yeah. So now when I set this up, it's still going to look like this. But what goes here now is p hat and q hat. They're not 50-50, they're now this.
So we're still using the same z-score even though it doesn't say in the second problem?
Well, this is coming off of this.
Oh,
So if we had done a preliminary study in order to create the same confidence that we want, namely 99%, yeah. I think this is 1400 something, if I remember correctly. I'm not going to say I did that in my head.
Times 0.25 for 2A.
Say again?
Why do we times with that 0.25?
How
Why?
or why? Okay. Well, the formula is this, and we have to assume p hat is 0.5 is the same as q hat, yes? The whole discussion we had about if I don't know what p hat and q hat are, our best guess is 50-50. So if I put 0.5, 0.5, 0.5 times 0.5 is 0.25. Okay, that's up.
1425.
1425,
Yeah.
is that after you rounded up?
Yes.
Okay. So we have a little over 400 less that we have to collect. Which is still a lot, but it's a lot less than 1800, that's pretty good. Okay. And we've already collected 42 of that, so that's fantastic. We just slap that into my sample. All right. So these are relatively easy problems because they pretty much have to give you almost everything. In this problem, you're going to calculate p hat. Q hat's going to come right off of that. You always have to find your own z-score. They're going to tell you how confident you want to be, and that's what tells you what the z-score is going to be. But these are fundamentally just plug and shove problems. one semester, have you guys heard that phrase before?
Yeah.
Plug and shove?
Yeah,
My favorite.
somebody had never heard it before, and their guesses were off. That's what that might mean. That's all I'll say about it. So last thing for today, and then I'll let us all out of this wonderfully tropical climate we have.
Okay, can I see a look at the problem? Sorry.
Which one? Sorry.
Very bottom there. I'll just take a picture. Let's copy it.
He records it.
This is fast, right? I'm not sure.
Yeah,
It's
it's-
an
yeah.
hour of video.
You can't be trusted today.
Well, that's true, yeah, today the recording will be, quite.
There will be several parts,
Do you think you can upload them tonight though?
of course.
Thank you.
Thanks.
I appreciate it.
Better.
First sign.
He's like, I work hard.
No, he didn't.
We know you do.
No, I'm listening. All right.
You gotta take another medical day.
So